Hi everyone, myself Chinmay, and today I am going to talk about Demultiplexer and its real-time application. So these are the topics I am going to talk about in this video. Introduction, Demultiplexer and its definition, block diagram of Demultiplexer, logic symbol of Demultiplexer, logic diagram of Demultiplexer, truth table and applications. I am going to tell you different applications of Demultiplexer and going to explain one of them in brief. So let's start. So first, what is demultiplexer? The demultiplexer is a combinational logic circuit that performs the reverse operation of multiplexer. Several output lines, one input line. Demultiplexer means one to many. A demultiplexer is a circuit with one input and many outputs. So demultiplexer is just opposite of multiplexer. In multiplexer we have several inputs and one output, and in demultiplexer we have several outputs and one input. Demultiplexer means one to many. Few types of demultiplexer. These are the types of demultiplexer: 1 to 2, 1 to 4, 1 to 8, and 1 to 16 demultiplexer. Just like we have in multiplexer. In this is 1 is input and 2 is output. In this 1 is input and 4 is output. Demultiplexer is the process of taking information from one input and transmitting the same over to several outputs. So let's talk about types of demultiplexer. The first we have is 1 to 2 demultiplexer. The second we have is 1 to 4 demultiplexer. The third we have is 1 to 8 demultiplexer. And the fourth we have is 1 to 16 demultiplexer. These are the outputs and these are the inputs. We have one input in all the demultiplexer as I told, and these we have different types of output. It can be 2, 4, 8, 16, etc. So now let's talk about the IC used in demux. These are the ICs we use for demux in laboratories. There are different demultiplexer ICs available, like 1 to 4 demux is 74139. For different demultiplexer like 1 to 4, 1 to 8, 1 to 16, we have different ICs we can use in laboratories. For 1 to 4 we have 74139 IC. For 1 to 8 demultiplexer we have 74237 IC and 74138 IC. For 1 to 16 demux we have 74154 IC, and for 4 to 16 decoder IC like 74159 we can use for demux. So this is the block diagram of demultiplexer. As you can see, it has one input and several outputs. This is the block diagram of 1 is to 4 demultiplexer. It has one input and 4 outputs. These are the select inputs S0 and S1. For 1 is to 4 we have 2 inputs. For 1 is to 8 we have 3 inputs, and for 1 is to 16 demultiplexer we have 4 inputs. We can change these inputs like 00, 01, 10, 11 to get different type of outputs. So this is the logic symbol of demultiplexer. These are the select input S1 and S0. We can change them to get different outputs like 00, 01, 10, 11. These are the data input D, and these are the outputs Y0, Y1, Y2, Y3. While making a truth table, I will explain how to make truth table using this. Draw this symbol. So this is the truth table of demultiplexer. Now I will explain how it is made. First we will take S1 and S0 0 0. When we will take it S1 and S0 0 0, the D will connect to Y0, and we will get Y0 D and everyone else 0 0 0. Now when we take S1 and S0 0 1, then D will get connect to Y1, and we will get Y1D and everyone else 0 0 and 0. Now when we take S1 and S0 1 0, D will get connected to Y2, and we will get Y2D and everyone else 0 0 0. And at last when we take S1 and S0 1 and 1, then D will get connected to Y3 and we will get Y3D and everyone else 0 0 0. So this is the logical diagram, and I explained how to make truth table using logic diagram of demultiplexer. So this is the circuit diagram of demultiplexer. Now I will explain how it is made using truth table. First we will write it I, which is data input, I, I, I. I is same for all. As you can see, it is connected to all of them here. It is connected to D0 also, it is connected to D1 also, and it is connected to D2 also. Now we will take the inputs S1, S0. We will write it 0, 0, then it will be 0, 1, then 1, 0, and 1, 1. Then we will take the output, which is D3, D2, D1, and D0. We will write it 0, 0, 0, I. It will now second one will be 0, 0, I, 0. Third one will be 0, I, 0, 0. And the last one will be I, 0, 0, 0. Now see what we can write. D0 equals to S1 bar, S0 bar. As you can see, it is low for both of them. We can write D0. Now we can write D1 equals to S1 bar, S0. So S1 bar, S0. Now we can write D1 equals to S1, S0 bar. So S1, S0 bar. And D3 equals to, we can write S1, S0. See, so first we got D0 equal to S1 bar, S0. So they see S0 bar, S1 bar. Now D1 we get S1 bar, S0. So see S1 bar, S0. This is for D1. For D2 we get S1, S0 bar. So D1 it is S1, S0 bar. And for D3 it is S1, S0. See S1, S0. So this is how the circuit diagram is made using the truth table. The most important part of the video, applications. I have written few of them here, but there are many more. First, the application of demultiplexer include the following. First, use in the communication system for transmission of data. Second, implementation of full subtractor using 1:8 demux. These two I am going to explain in brief, and second one I am going to explain in full brief. Third, implementation of Boolean function. So you can also use demultiplexer for implementation of a Boolean function, like you used multiplexer. Fourth, demultiplexer are used in control system microprocessors to enable or select a single signal from a number of signals. The ALU output is stored within particular radars with the help of demux. Last one, designing of combinational circuit. So you can also use demultiplexers for designing of combinational circuits. So now I am going to explain full subtractor using 1:8 demux. This is one of the most important applications of demultiplexer. Similar to multiplexers, demultiplexers are also used for Boolean function implementation as well as combinational circuit design. We can design a demultiplexer to produce any truth table output by properly controlling the select lines. So these are the select lines. For 1:8 demultiplexer, as I told, there are 3 select lines because as per the formula we have 2 to the power n equal to number of outputs. Okay, and here n equals to the number of inputs and here there are 3 inputs a and b and c, so we have 2 to the power 3 equals to 8 outputs. Here are 8 outputs, y naught, y1, y2, y3, y4, y5, and y6, y7. D in is the data input and this is the diagram. So this is the truth table of full subtractor. This is, as for the binary term, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. We have 3 inputs and 2 outputs. A, B, B in is input. We can also write it C. And for output, we have D equal to difference and B out equals to borrow. First, 0, 0, 0. So we will get difference 0 and B borrow also equal to 0. Then we will take 1, which is A equal to 0, B equal to 0, and C equal to 1. So difference we get is 1. How? 0 minus 0 is 0, and 0 minus 1 we have to take a borrow. borrow equal to 1 and 0 minus 1 is also 1, so difference is 1. For third, we will take a equal to 0, b equal to 1 and c equal to 0. So we will get difference 1 and borrow 1. 0 minus 1. So we will have to take a borrow. So we will get borrow 1 and 0 minus 1 in binary times is 1. So 1, 1 minus 0 is 1. So we will get difference 1. Fourth, we will take a equal to 0, b equal to 1 and c equal to also equal to 1. So difference will get 0 and borrow equal to 1. How? 0 minus 1 we have to take a borrow, so we will write the borrow here 1 and 0 minus 1 by terms is 1. But 1 minus 1 is 0, so we will get difference equal to 0. So fourth, we will take a equal to 1, b equal to 0 and b in equal to 0. So we will get 1 minus 0 is 0, 1 and then also 1 minus 0 equal to 1. So we will get difference equal to 1 and borrow equal to 0 because we do not have to take a borrow here. But fifth, we have to take a equal to 1, b equal to 0 and c equal to 1. So 1 minus 0 equal to 1. We do not have to take a borrow here. Then 1 minus 1 is 0. So we'll get a difference 0 and borrow also equal to 0. For sixth one, we have to take a equal to 1, b equal to 1 and c equal to 0. So 1 minus 1 equal to 0 and 0 minus 0 equal to 0. So difference equal to 0 and borrow also equal to 0. For last one, we have to take a equal to 1, b equal to 1 and c equal to 1. So we'll get 1 minus 1 is 0. Then after that 0 minus 1 we have to take a borrow here. So we'll get borrow 1 and d equal to 1. How? 1 minus 1 equal to 0 and 0 minus 1 in binary terms we will get d equal to 1. Now let's do the simplification here. For first, we will get the full subtractor output D, which can be written as D equals to F A B B. Okay. So where is the difference high? Difference is high for 1, 2, 4 and 7. So we'll get minterms equal to minterms we will get 1 comma 2 comma 4 comma 7. Here difference is high for 1, 1, 1 and 1, and this is for difference D. We'll equate it to D. Now for borrow, we will write B out equals to F of A, B and C. I told you B in, we can write it C. You can give it any name, its input. And for minterm we will get B out equals to, now where is borrow high? Borrow is high for 1, this is 1, for 2, for 3 and for 7. Everyone else it is 0, 0, 0 and 0. So we'll get minterms 1, comma 2, comma 3, comma 7. Now we can write it here. I will write it here. See, B out, we for difference we can write it minterm 1. We can write minterm 1 as A bar, B bar, C bar, plus for 2 we can write it A bar. See, for 2 it is A bar, B and C bar, plus the third minterm is 4. So we can write 4 as A, B bar, C bar. So A, B bar and C bar, plus the last minterm is for difference is 7. So 7 we can write A, B, C because it is high. A is also high, B is also high and C is also high. So A, B and C. From high I mean 1, 1, 1 and low 0, 0, 0. Now for borrow. Borrow I can write B out equals to, for first minterm is 1. So 1 we can write A bar, B bar, C. So A bar, B bar, C. This is the simplification I am doing. Then for second minterm it's 2. So we can write 2 is A bar, B and C bar. So A bar, B and C bar, plus the third minterm we have is 3. So A bar, B, C, A bar, B, C, and the fourth minterm we have also 7, because here borrow is higher at 7. We can write it A, B, C, and then so I just did the simplification. As you can see from the above table, the full subtractor output D can be written as D equal to F A comma B comma B in. I wrote B in equal to C. You can also write it D equal to sigma M, which is min term 1 comma 2 comma 4 comma 7, as I explained. D I can write A bar B in plus A bar B bar plus A B bar B in bar plus A B in bar. I told you how it is written, and the borrow output can be expressed as B out equals to F A comma B in min terms 1 comma 2 comma 3 comma 7. I told you how the min terms come. For borrow, I can write it A bar B in plus A bar B in bar plus A bar B in plus A B in. I told you how these all the terms came in the just before. From these Boolean expressions, a demultiplexer producing full multiplexer output can be built, configuring the 1:2 demers such that with it gives the minterms at the output. Now I will tell you how the full subtractor output can be built. So this is the circuit diagram made using the output we got, and by logical ORing these minterms, the output of difference and borrow can be obtained as shown. So what was the minterm we got? For difference we get minterms equals to sigma m 1, comma 2, comma 4, comma 7, and for borrow we get b out equals to sigma m, we got 1, comma 2, comma 3, comma 7. So D in 1 is to a demarc. These are the input lines which I told you we can write 0 0 0 0 0 1 1 0 0 1 1 1 etc. So why not and why 6? We are not getting here. See, there is no 0, there is no 6. So we will just leave it like this. There is no also 5 also. So we will also leave the 5, 6 and 0 like this. Now for D, we got D 1 2 4 7. So 1 here, this is 2, these are connected all. See 1 here, this is 2 here, and 4 we got here, and 7 we got here. So these 4 are connected for difference, and from borrow we get 1, it's going down here, this 2, it's going down here, 3, it's going down here, and 7 here. So this is the circuit diagram we made using the outputs and minterm we got. So this is the second application I am going to explain. It is communication system. Communication system use multiplexer to carry multiple data like audio, video and other form of data using a single line for transmission. This process makes the transmission easier. The demultiplexer receives the output signals of the multiplexer and converts them back to the original form of the data at the receiving end. The multiplexer and demultiplexer work together to carry out the process of transmission and receive and reception of data in communication system. So what multiplexer do is multiplexer merge the different lines into one, which makes it easier for transmission. And what demultiplexer do is when these merged lines received at the endpoint, demultiplexer demerge them and they both work together to make the transmission easier. So these are the advantages of demultiplexer. The advantages of demultiplexer include the following. The efficiency of the communication system can be improved with the help of the multiplexer and demultiplexer combination. Second, a demultiplexer separates back the mutual signals into streams. Third, its function is quite opposite to multiplexer. Fourth, it can be used as a decoder in the security. Fifth, the combination of multiplexer and demultiplexer is used for transmission of audio or video signal, as I told you in the communication system application. The disadvantages of demultiplexer include the following. Bandwidth wastage can be occurred. Second, delays can be occurred due to the synchronization of the signal. Thank you. Thank you. Hope you liked my video.